Hey there, yeah, so I didn't get to a video on Monday or Tuesday, but I'm feeling a little bit more human today, so section 4.6, numerical integration, we're going to do this, what I like to call the easy way. See, we talked about earlier, we talked about how when we're estimating area, come on, alright, I don't want that one, I wasn't patient. When we're estimating area, right, under a curve, we talked about how we could use rectangles. Let's pretend I could draw straight up and down rectangles, right? And we might use upper limits, we might use lower. What Simpson and the Trapezoidal Rule have said is, what if we didn't always use rectangles, but maybe we used trapezoids? I can't draw that. Yeah, so we're getting trapezoidal. And Simpson's rule. Alright, so these are two different rules that are much like the sums that we started with. They're just using various shapes in order to do it. So if I wanted to use the trapezoidal rule and Simpson's rule to approximate the value of x squared from 0 to 1, what I'm going to do is I'm going to, okay, normally I click on there, but I already have it up here in two different places. Look at that. So I want x squared, and I want it from 0 to 1. So I'm going to move my a value to 0, my b value over here to 1. I'm going to make sure n equals 4. Alright, that's what it asked for. And I'm finished. Simpson's rule says this is 0.33333. The trapezoidal rule, we'll go back up here, hit the trapezoidal rule for x squared from 0 to 1. Number of trapezia, 4, so we could slide this if we need more trapezia, 0.34375. And the exact, we know the exact, because we can find the exact. This is x cubed over 3 from 0 to 1. This is 1/3 minus 0, which is 1/3. So in this case, Simpson's rule happens to give us an excellent approximation for the actual area. In other problems, it might be the trapezoidal rule gives you the exact area. In still more problems, maybe neither one, but they're all kind of close to the same exact answer. You can do this, and remember, if you need to find the exact answer and we don't have the skills for it, hint, hint, problem number 5, maybe you could use Desmos. Alright, this is a short one, this is a quick one, but we're not going to compute these by hand. We're going to go ahead and let GeoGebra handle that for us, just like we did for upper and lower sims eventually. Alright, short one. Thanks for listening. Bye.